Hello and welcome to the Consistency Project Podcast. My name is Patrick Cummings. As always, I'm here with E.C. Sinkowski. Every week on the show, we aim to simplify the science of nutrition, health, and fitness, cutting through the noise to focus on the principles and practices that will help you perform better, feel better, and live better. Thank you so much for tuning into the show. Hello, E.C. Good to see you.
Hey there. How are you?
Fantastic. We're going to do a little research review this time, which is when, actually, I'm going to, instead of assuming, how do you come across these research studies that you feel like are worth talking about? Is it you get a number of emails every week? What do you do to actually select these?
Yeah, I have alerts set up on PubMed for a weekly dump or index of things related to nutrition that are also human studies.
Yep. Okay.
And so I try to review them weekly. I will say with the app that came out, that got tossed to the side for a bit. But I try to review them weekly. And then, typically each week there's probably about 100, 130 to look through. And I just kind of look through titles and stuff that I think are interesting to the group. And I probably open 10% of those or so and kind of look at what they did and look at the end outcomes. And I think there's a lot of stuff that I do that with where the outcome's related to my recommendations, but it doesn't really change my recommendations. Mm-hmm. So it kind of is like another line of reasoning that I use to make my recommendations. And so sometimes I'm like, this would be interesting for people just because it doesn't necessarily change my opinion. It's still related to how do I come to that conclusion, right? So that's sort of the idea here is oftentimes maybe we don't need a whole podcast on it, probably because we've had one on it, but maybe it adds just more evidence for topics that people care about. Yeah.
Do you remember the last time you read one and it really changed your mind about something, or is that maybe that hasn't happened given the amount of work you do to kind of figure these things out in the first place?
Yeah, hasn't happened a ton. I'd have to think about that in the sense of did something really change my opinion? Which, I have to be careful of that, right? Because you don't want to just be like, I'm finding the stuff that falls in line with what I believe versus not. But I think nutrition really has these basic requirements. And then once you understand that that's what we need from a physiological point of view, then you start to see how the different diets and the different plans either fall into that or do not, right?
Yep.
Yeah.
Got it. Okay. So we got 3 different papers we're going to look at today. One about diet and osteoarthritis, one about protein intake and recovery, and the third and final will be carbohydrate, insulin model, and glycemic response to food. So let's just jump right into that first one, diet and osteoarthritis. Let's do a little bit of background on the subject.
Yeah. This is the Asadi paper in the show notes, and osteoarthritis, again, is known as the wear and tear one. We all get it. We actually talked about it briefly in the last podcast when we touched on collagen towards the end there. But yeah, osteoarthritis really has the potential to affect any joint in the body. It's very common in the knees, but also hips and spine. And what happens is there's a lot of pain or stiffness or swelling, and it can also really affect somebody's joint mobility. And it really doesn't just affect workouts. You don't want to think about it as, it just affects people's, high rep squatting or something like that. But it can affect somebody's ability to go to work, especially if they're on their feet all day or something like that. And then even might decrease sleep, just general overall mobility and quality of life. And it's a huge problem. 600 million people were diagnosed globally in 2020 and expected to be 1 billion by 2050. And it's really just kind of, again, this breakdown of cartilage, and it ultimately can lead to even changes in the soft tissue and the bones surrounding the joint as well, not just the cartilage. And it's largely driven by inflammation. And so because it's so common and because it's so debilitating, we're all very interested in what could potentially be driving it, what's the root cause. And so we definitely look at nutrition. I just want to remind people that, like, when I say inflammation, when we hear things are due to inflammation, you really want to think about it as it's these signaling molecules from the immune system that are quite useful, especially when it's an acute scenario. It's the immune system recognizing there's a problem and it's trying to clear the problem. The problem is when it becomes chronic, then the immune system's quite powerful in trying to clear the problem that it then can be damaging. And so that's what you could have in something like osteoarthritis. And so again, it's so debilitating and so common that we're really trying to look at the different ways to address it, and nutrition is one of those areas that we look at.
Got it. All right, so tell us a little bit about the Asadi paper that we're talking about this time around.
Yeah, so this is one of those systematic reviews and meta-analysis. I feel like I only talk about those. I try not to, but we like them because they pull together research from lots of different studies, and they were specifically looking at these randomized controlled trials. Again, those are the trials that give us the highest degree of control where we can say, okay, this thing actually caused the outcome, not just as associated with the outcome, but they were looking at, okay, what's the effect of dietary interventions on pain and physical function for people that have osteoarthritis? Now, they found 9 randomized controlled trials to kind of fit within their criteria that they were looking for. And the dietary interventions include things like reduced calorie diets, aka cutting calories, the Mediterranean diet, which we've talked about, anti-inflammatory diets, which we've talked about, plant-based diet, as well as even low-carb, low-fat diets. And basically the conclusion that they came to was that, yeah, dietary interventions could improve pain and physical function, but it was really only the reduced calorie diets that did that. Not the Mediterranean diet, not the anti-inflammatory diet. And I think intuitively this makes sense. We talked, like I said, about anti-inflammatory diets kind of recently. And I think there's this idea in nutrition that if you just add some anti-inflammatory foods, like, oh, I'm just going to go eat some blueberries or some other superfood to my diet, then like, poof, now my diet's anti-inflammatory. When really you want to think about it as the strongest anti-inflammatory diet is the one that allows you to maintain a healthy weight. And that, again, is because fat tissue, adipose tissue, is inflammatory. It releases these inflammatory signals that ultimately can contribute to joint pain and something like osteoarthritis. And so even absent of like looking at what happens to inflammation and the inflammatory signals, one of the great things about losing weight for osteoarthritis is also just the reduced pressure on the joint. It's something like every pound lost reduces pressure on the joint by 4 pounds, right? So this is, I think, why this study found that the cutting calories diet was the most successful in terms of joint pain and function. Like, sure, it probably reduced inflammation by way of those signals coming down because there's less fat on the body, but it's also reducing any pain because there's just less pressure with every step the person takes.
Yep. Got it. So it was more of a quantity solution than a quality solution.
Yeah.
Yeah. Interesting. Beyond that, any other takeaways that you or that we should have from the study?
Yeah. I mean, I think the first thing is that maintaining a healthy weight is in fact tied to health. I mean, I guess that's sort of obvious when you say maintaining a healthy weight, but we have to remember that weight and health are inextricably linked. And I do like to, make sure that we understand that weight alone doesn't define you. It certainly doesn't define your whole health picture. And also, maintaining a healthy weight doesn't guarantee health forever and ever. But we do have this relationship between the two, that there is some weight that goes against your health goals. Weight is not irrelevant. And I do feel like there is sometimes a trend to sort of just write it off and say it's not important. So yet again, another study suggesting otherwise, right? Secondly, I do think we spend a lot of time worrying about things like the best fruit or veggie, right? I mean, I'm sure maybe I hear that question a lot with something like the 800-gram challenge, but it's like, okay, is this really the best place that I can get my vitamins and minerals or my fiber? Or did I get enough blueberries today, as I joked about earlier? Mm-hmm. I think we can get really lost in the weeds of quality. And as you kind of hinted at, this was really a quantity-driven outcome. Yeah. And I think ultimately we have to remember that the best nutrition diet will give us both, will give us quantity and quality. And I think it's sort of interesting. I love, obviously, quality. I start people on the 800-gram challenge. We focus on these fruits and veggies. Yeah, we get the vitamins and minerals and fiber. But I think one of the best things from it is that it helps people control quantity. It's not about, did I get enough vitamin C for my 800-gram challenge? It's the fact that it has this displacement effect and helps people keep quantity in line, which is so tightly related to these health outcomes that we care about. And then I think the third thing here is just about osteoarthritis. The article does mention, although it didn't really look at it, how exercise is so helpful to osteoarthritis, which I think is a little bit counterintuitive. Probably not to our audience, but I think it's one of those things that people would think, oh, I shouldn't do exercise because my joints hurt, but it actually does seem to really help. And that really resistance training and strength training can help reduce the pressure on the joints. So it's going back to, I know we hinted at this podcast last week, but my first kind of lines of defense before I think about potential supplements for osteoarthritis would be, okay, let's maintain a healthy weight. Let's make sure that we're exercising, specifically resistance training, because those are what we see kind of time and time again show up in the literature versus necessarily, let me go eat, again, more blueberries. And in fact, we had a question on osteoarthritis back in the spring of 2021. So I went back to it, and that's pretty much what I said there. Maintain a healthy weight and exercise were the first 2 lines of defense.
Got it. Cool. Okay. So let's jump into our second review then. Protein intake and recovery. What do we got with this one?
Yeah, I think this is the Press D article in the show notes. Protein, hot topic around here. So we're back to it. Couldn't get a week away from protein. And we typically talk about it from that gaining muscle perspective, but another reason that we like protein is from the recovery perspective. Now, I think that's a little bit related. Workouts cause this exercise induced muscle damage, and then protein is some of that stimulus which helps regrow to stronger muscle. But this article was really looking at, okay, let's take a group of people who have this exercise-induced muscle damage, which can lead to delayed onset muscle soreness. And then we're going to look at protein intake, and does that help them in terms of better recovery and ultimately their performance thereafter. And so it was a small study with 16 people, both male and female. And they did this high rep eccentric, or the lengthening exercise to damage the muscle. And then days later, they tested the individuals on their vertical jump and like their force production. And the individuals were given either low or high protein intake. And the low protein intake was 1.2 grams per kilogram, which is 0.55 grams per pound. And the high protein intake was 2 grams per kilogram, or 0.9 grams per pound. And the athletes were vegetarian, which is a point that I'll come back to in a second. But the findings here, quote, there was no difference in recovery of strength, power, and soreness after exercise-induced muscle damage in people who follow a vegetarian diet while consuming the lower and upper ends of protein recommendations for athletes, end quote. So in other words, more protein didn't help with better recovery, and therefore they also didn't have better performance because of the higher protein.
Got it. Maybe let's tackle that vegetarian angle first. What's the importance of that, if there is any?
Yeah, we did a Quick Bites recently. Sometimes I want to say recently. I'm like, oh gosh, was this 6 months ago at this point? But I think it was recently. We did a Quick Bites recently, whether people who are vegetarians or vegans should have a higher protein intake because of the lower bioavailability of plant proteins. And basically I said no in that. And this article sort of starts off the same way and says, okay, well, there's plant proteins that have less bioavailability. And so their prediction was that the higher protein intake would actually be necessary for their recovery, yet that's not what they found. And so in their discussion, kind of reflecting back about what their hypothesis was, I think what is so valuable is they're saying, hey, yeah, we can look at something like the bioavailability of plant proteins, but we actually need to take it a step further and look at the outcomes we care about to then make a conclusion about what we should do with, let's say, our vegetarian or vegan athletes. And I think this is something that we talk about here on the podcast all the time, but I just like to reiterate it. Like, we can have a theory about the bioavailability and maybe, oh my gosh, that's going to result in less muscle mass, or oh my gosh, it's going to result in less performance. But then we have to go test muscle mass, or we have to go test performance to really see if that theory plays out. Because if you stop at the test that just looks at the bioavailability based on like a petri dish or some sort of, I don't know, lab experiment, you might come to the wrong conclusion, where if you then go out like they did and actually give the athletes the protein amount and actually measure their performance, you might realize that you come to a completely different conclusion. And so that's what I really liked about this is like, yeah, they found that we could have these theories about bioavailability, but the more protein didn't actually result in better performance.
Mm-hmm. You mentioned in the study they had sort of an upper limit and a lower limit of intake, and that neither seems to have had an impact on the actual performance outcomes. So I bring that up to just ask, does that change your thoughts on where that lower limit should be or could be?
Yeah. And kind of like thinking back to your question when we opened up the podcast, like at first blush, this would be something that would be at odds with my protein recommendation. So does this affect that? And this is where then you have to kind of dive into the context of the study to then understand who it was for and what are the limitations of it and why it may or may not change your opinion. And so it doesn't really change my recommendation as a baseline number of 0.7 grams per pound for people, because a weakness of this study, especially for our audience, is that the individuals in this study were untrained subjects.
Got it.
So this would not be something that we could extrapolate or say is going to happen for people that are regularly training with resistance training. That maybe the higher level of protein intake for people that are regularly training actually does result in better recovery or better performance. And so that's why we kind of have to dig into those details to make sure that we're making the right conclusion. I will say that their lower amount of protein, their 0.55 grams per pound, is the lowest that I would kind of put out there for people, because that's also in line with the amount of protein that we find helps prevent sarcopenia, the natural loss of muscle mass as we age. And so I do think that there's people who they might not need my 0.7 grams per pound, but they're going to be either an untrained population or a sedentary population that's not really interested in kind of the muscle mass gain, which is so common for our audience. I will say, just so that people know, even for that sedentary or untrained population, I don't think 0.7 grams per pound is that outlandish, and it's certainly not that harmful, especially in our modern food environment, because I think what happens is that increase in protein, even if they don't need it for their own muscle mass gains, that it can help with satiety, which is such a big factor in being able to control weight, right? And with having processed food around us. And so this is where, like, yeah, I can appreciate that 0.7 grams per pound might not be what everybody needs from a physique perspective or even from an optimal health perspective. But I think realistically in a modern food environment, there is still a broad utility of that number.
Got it. All right. So that was our second of three. Let's jump into our third, which is going to be about the carbohydrate insulin model and glycemic responses to food. What do we got?
Yeah, this one was interesting. I kind of stumbled into it almost accidentally, but it was kind of like cited by one of the studies in my review index. So this is a loose study in the show notes. They were looking at the effects of high and low glycemic meals on hunger and like how hungry somebody is, but also not just how hungry they are, but how many calories did they actually eat at the next meal. And I think this is one of those things that has become so accepted. I know I believed it for a period of time, yet we don't really have the evidence of it, that when you eat these high glycemic foods or meals, you're more hungry and you're going to keep eating more. And so anyway, that's exactly what they were testing at. Now, the greater context of this paper is really to test the carbohydrate insulin model. Now, the carbohydrate insulin model we've talked about before, but it's basically the theory that's been put out there is the main opposition to calories in, calories out. I kind of hesitate with main opposition because it's been disproven and it's not really that mainstream. But anyway, certainly our audience has heard about it. Some people incorrectly believe that it's not calories that drive weight gain, but instead it's the type of calories that drive weight gain. And specifically the type of calories that drive weight gain according to the carbohydrate insulin model would be, of course, these high glycemic carbs. And the explanation of the carbohydrate insulin model is that when you eat these high glycemic carb foods, insulin goes up to store the energy. So far, correct. And then this high insulin level traps the energy in the cells. It traps the fat molecules in, let's say, your fat cells. So you can't get after this energy that's in your fat cells, such that other cells can start to become starving for energy because insulin is so high. And so you become hungry, and it's this hunger that drives the person to eat again and then eat too much food. And it's this vicious cycle leading to weight gain. So calories in, calories out really says it's the eating in excess that drives weight gain, where the carbohydrate insulin model is saying that weight gain is the result of hunger from people eating high glycemic carbs. Kind of puts the blame on a different area, right? And we've talked about how this has been disproven with these metabolic ward studies where they can totally control calories and watch everything that people eat. But I think this study was still really interesting to me because it relates to hunger, which is always a hot topic. But then I still get lots of concerns and questions about insulin spiking. So I was like, oh gosh, we definitely have to look at this one.
Yeah. Okay, cool. So what did the study look at? What did it say?
Yeah, there was 3 groups. One group got a low glycemic index meal, one got a kind of a medium glycemic index meal, and then one, of course, got a high glycemic index meal, where the glycemic index refers to how high the blood sugar will spike after eating that food. So white bread, for example, is known as a high glycemic index, high GI food, and it causes a greater blood sugar spike than, let's say, if you were to eat the same amount of carbs as spinach or something like that. So what was really interesting about this is the meals they gave, even though it was low, medium, and high GI, they were the equal number of calories and an equal macronutrient distribution, which is important because, let's say, like protein can help satiety and stuff like that, right? So equal number of calories, equal macronutrient distribution. It was just that the carbohydrate source in each of the meals differ, and they just basically got more and more processed. Now, the meals were pretty large, like 650 calories for women and 900 calories for men, but they gave them this meal in the morning. They waited 5 hours, and then they let them eat whatever they wanted, and they measured what they ate when they ate whatever they wanted to see if that high glycemic meal made them eat more or made them more hungry.
Yep.
They also happen to look at things like glucose levels and insulin levels and hunger hormones like GLP-1 and leptin, etc. Okay, so some really interesting results. There was no difference in the calories consumed between the groups at the second meal. So said another way, the group that had the high GI meal did not eat more calories 5 hours later. There was also no difference in reported hunger between the groups. So again, said another way, the group that ate the high GI meal was not more hungry 5 hours later. Mm-hmm. So there's so much out there that, again, I believe this too. You eat carbs spike your insulin. This makes your blood glucose fall really rapidly, causing you to be hungry. And you eat again, you go up and down on this kind of roller coaster. And this is ultimately what leads to weight gain and hyperinsulinemia and all this other stuff. And that's not what the study found. That hunger and meal size was not related to insulin spiking.
That is really interesting. You had mentioned, I think, that they had tracked on a number of other things, including they took blood samples. Anything worth mentioning there?
Yeah, they'll do a lot. We won't touch on all of them. But they did look, again, like was there a relationship between glucose or leptin or insulin on that second meal? And they didn't find really any correlation. So insulin, in fact, had a weekly inverse correlation. So said another way, when they had higher insulin before that second meal, it reduced their caloric intake. And we actually talked about this on the How to Hack Hunger podcast, that higher insulin responses typically are related to greater satiety and lower food intake in subsequent meals, which this study falls in line with. And it makes sense because insulin is a storage hormone. So if insulin is really high, your body's in storage mode. It's going, wow, we've got lots of energy around. You probably aren't going to be hungry. And that's what they found, although it was a very, very weak kind of association. And again, they looked at things like glucose and leptin, and they didn't find any relationship between what the levels are before that second meal and how much they ate. And so the point here is people really need to stop fearing insulin spikes and glucose levels and really start diving into, if they're worried about their health and optimizing that, what is the total quantity I'm eating per day? And whenever I say quantity, I mean calories and macros. And to measure that. And guess what? It's way harder than looking at what type of food am I eating, or what am I eating it with, or what specific superfood, or even my insulin spike. It's way harder than doing that because you have to collect the data across, of course, the entire day, and then really across weeks and months, versus just sort of kind of point looking at any of these individual variables. But that's what you really want to take a look at if you want to optimize kind of your health. Now, if you're already at a healthy weight and you already have your blood sugar in a healthy range, then you don't need to worry about, insulin spikes and what your glucose level is at any given time. Those are already telling you that the system is working. And so this is basically another nail in the coffin for the carbohydrate insulin model, that higher GI foods and higher insulin release does not result in more hunger, does not result in greater energy intake. I will kind of finish though with, I do think there is some phenomenon where people eat something like a donuts, maybe more than one, eat something like a couple donuts and are hungry soon after.
Yep.
The point here is not that phenomenon never occurs for people, but you're not hungry soon after because of glucose levels or because the insulin went up. You're likely hungry soon after because the volume was low, in the sense of, you ate a bunch of calories, but your stomach didn't really stretch out like fruits and vegetables. Or maybe you didn't really have that much protein, which helps satiety. Or maybe you just like that sugar high. You feel good after eating those foods for like the dopamine response that we've talked about. Mm-hmm. I think that is what is kind of driving people to eat again, more so than the insulin level or the glucose level.
Got it. I've never just eaten one donut.
I know. I was like, maybe you have a donut. Donuts.
Okay, real quick. This might feel a little tangential or unrelated to the subject at hand, but continuous glucose monitors, which we've talked about before,
yes,
and that you're not a fan of,
no.
are they working under the assumption that this carbohydrate insulin model is in fact correct, or are those things sort of unrelated or differentiated enough to be not worth talking about?
Yeah, I mean, I think it is sort of working under the assumption that correcting insulin spikes is theoretically the path to health. Now, again, there's always so much half-truth in this. Like, yes, if you excessively spike your insulin all of the time, I'm going to tell you that your quantity is too much. But it's kind of looking at it from the wrong end. Instead of trying to look at my insulin spikes, which can be healthy and normal, or could be excessive and problematic, let's look at the quantity that we're eating and figure that out versus trying to look at these individual spikes to figure it out. So I think they are related, but they're just tackling the problem from the wrong angle. They're kind of looking at the response instead of what would be driving that response.
Got it. And last question. I don't remember if we've done an episode on the glycemic index before. I know we've certainly talked about it. I just don't remember if we've done a full episode. But I bring that up just to ask, based on what we just talked about here, do you give any validity to even thinking about where a food is located on that glycemic index, or even does the glycemic index sort of like, that's a bit of a distraction from what we should be paying attention to?
We probably talked about it 5 years ago, Patrick. You don't remember? No. So there's a few problems with the glycemic index. To try to keep it brief, it rates foods assuming you ate a certain amount of that food. That's a big assumption. We don't end up eating the same amount of carbohydrates of spinach as we do ice cream, just when left to our own devices, for example. So that's a big problem. Doesn't take into account what did the person actually eat. It also doesn't take into account the fact that somebody could have an insulin spike, but yet still have healthy blood sugar. And I always like the example of Thanksgiving. There's lots of people who had a very big spike after Thanksgiving dinner, but they still have healthy blood sugar. So it doesn't take into total quantity of the entire day. But again, there's lots of stuff that like has some slight utility. And I think what happens when you look at stuff like the glycemic index is, guess what ends up being more on average low in the glycemic index? Fruits and veggies, whole foods. Guess what ends up being high? Processed foods, crackers, chips, all of that stuff, right? So when people follow like, okay, I'm going to eat more low glycemic foods in the diet, they end up eating more whole foods, and by default, oftentimes their total quantity gets corrected, which is what is the driver of the outcome they want, versus the fact that their insulin spiking propensity has changed.
Got it.
Right. So there can be some really positive downstream effects of people focusing on low GI, even though the physiology isn't exactly what they think it is or how it will actually play out.
Got it. All right. Thank you, EC. Thank you, everybody out there, for listening. Do make sure you're subscribed to the show wherever you are listening or watching this. And do make sure you check out the 3 Pillars Method app now at 3pillarsmethod.com, the app that EC has been working very hard on that I recommend. EC and I will be back next week for a brand new episode of the Consistency Project podcast.